All right, so 4513, there's the course description. This is whether or not you read it. Because this is a core course, I say thank you for taking it, but you don't really have a choice. We're going to be looking at a lot of basically data communications networks. So what's described here is basically covering a lot of the course material itself. So we'll look at network routing beyond just actually transmitting the data, what happens once you transmit it itself. We're also going to be focusing in on some more specific applications of it, so some actual specific use cases, and look at how you could use those types of sort of protocols or devices yourself. So the course coverage will include stuff like looking at mesh networking. So a lot of this is pretty common now in sort of Internet of Things applications. We're going to be looking at, in previous lectures you went over digital and analog transmission methods. And you hopefully would have covered stuff like, okay, what does different diagrams look like of the received signals? What we'd like to do in this course is actually take that a little further and also take that to some more real life applications. So in some of the labs, which I'll show you in a second, we basically are going to be trying to receive messages and actually over the air, understand how you'd actually go about building a receiver. We'll also be looking at some of the how you would analyze protocols themselves, how you would look at different layers of IP and different layers of protocols. So that's some of the other topics we'll be covering in the course. So the labs are going to be different from previous years. And one of the things we're looking at doing in the labs this year is a lot of them are going to actually use a wireless communication system. They're going to use something called this RTL SDR, and we'll talk a lot more about that in the labs. But this is basically a software-defined radio stick, which will let us receive broad spectrums of radio. From that, we can actually go and sort of develop a better understanding of how do received signals actually look like in real life. What sort of problems would you see when you go to implement wireless communications or wired communication systems, and how might you sort of solve them? So this course really builds upon everything you've learned in analog electronics, some other communications courses as well, and tries to take it to the next level in terms of both applications and also practical considerations around usage. There's a few references offhand that you might find useful. So the first two references here, this TCP/IP guide is available in like a large book. It's also available online. So it was originally entirely an online reference, and there's basically a printed version of it. This reference will be for when we go into the course material, basically the first few weeks, probably most of January. We'll be looking a little more at protocol level stuff. After that, we won't be using this book very much. Anyone in computer engineering, though, this will be the same reference used for 4404. So it can be valuable to get a physical copy if you plan on using it quite a bit. The other reference we'll have is for the labs, effectively. There's actually a book on using the device. We're going to be extending quite a bit beyond what's covered in this book in terms of the received signal types. But this book will give you a really good background. And this is also available as a free PDF online, as well as with all the examples. So some of the labs were actually built basically from some researchers that had published this book itself. So that's a good resource as well. Some important dates that you probably should care about. So there's the two drop dates, so February 4th and March 11th. If you decide that maybe this semester has too much workload for you, just be careful of those dates to make sure that you are aware of when they occur. There's sort of actually 4 classes that will be missed. So 2 of the classes are planned. There's a study break. I'm going to be away for 2 of the classes as well that just happen to align with the study break. And this will actually be used for project work. So this will give you quite a bit of time. Hopefully this works to your benefit here to work on this project. And there's a short report that will be due after this. So I'll talk more about all the project stuff in a moment here. There's also 2 exams. So there's a lab exam during the regular exam period. The lab exam is basically confirming that you've done the labs. The lab exam will be a relatively short, sort of 1-hour exam that will cover material done in the labs themselves. The last class on April 8th, so this is the last class for all of the university. This class will just have sort of some review material for the exam, and then the exam will be in the regular exam period. So the topics we're going to work through is basically, we'll begin on Wednesday with a bit of a history of networking and networking layers. We're going to move next week into we'll be moving to different areas in the networking stack. So we'll be talking about routing protocols briefly, as well as network devices. So this will be a lot of sort of a really brief TCP/IP type intro. We'll be talking a little more about sort of lower layer networking stacks. So what this course focuses on compared to the 4404 computer engineering course is this will focus a lot more on sort of this physical layer stuff. So you're going to see a lot of topics talking about physical layer or MAC layer. What these are actually saying, okay, you can learn about TCP/IP, but how do packets actually get sent over the wire? How does the wireless device know that it's receiving data? And so we'll be covering both wired and wireless topics there. There'll be then quite a bit on expanding digital transmissions theory. So some of this will be a bit of recap of previous digital transmission theory classes, but we're going to be looking in particular a little more at real life considerations around the usage of it. So one of the objectives of this is, you've learned about or hopefully you've learned what, PSK and QAM, how these work. But we want to say, okay, when you implement it in real life, what happens? And that's one of the objectives here. We'll then be moving into error detection and correction. So this is an important area for a lot of different protocols, which is how do you detect and fix errors that are occurring over the bus. Finally, we'll be looking at sort of 3 real-life protocols. And this is both to teach you about protocols that are relevant to sort of the industry and your future career, but also to teach you about how various fundamental applications or fundamental digital transmission theory is applied in real life. So the first one is we'll be talking about something called code division multiplex access, CDMA. This is used in GPS. So we'll first introduce the CDMA theory and then look at how GPS receivers actually work. And a similar thing, so digital video broadcast, DVB, will be discussed. And we'll use that to sort of understand one of the newer methods used for actually transmitting data over a channel, these LDPC codes, which are used in all sorts of current protocols. And finally, we'll look at a little more broadly Wi-Fi 802.11. So again, what sort of requirements are there on these devices? What sort of applications, what sort of underlying codes are used on them? The general schedule is something like this. So normally what I'm trying to do is not have too long of a straight lecture, and I'm going to try to stick to this schedule fairly reliably. Obviously the first today and probably the next day won't be to this schedule. So on the Monday lectures, the first 20 minutes will be a summary of sort of the previous 2 lectures. As well as if you have any questions. It'll also be any summary of lab stuff that happened, because the last time we have together will be in the lab, and so the Monday lecture will let us catch up on that. And then there's about 50 minutes of new material being introduced. So the new material section will typically be the only section that's recorded, and that's what's posted online. So the recap stuff probably won't be, just to keep stuff as concise as possible. So in lieu of a midterm, there's an in-class quiz, and it's a very short is the idea. So you'll notice there's only 20 minutes dedicated on Wednesday mornings to the handing out, the execution, and the collection of this quiz. So you can imagine this is not supposed to be something you have to study intensely for. The objective of this is to give you, ability to rehash the previous 2 lectures of material and sort of get a better feeling for how you're understanding this material without having to wait till a midterm or exam to do so. And after that, again, there's a similar 50 minutes, hour of new material. The labs themselves will have they may or may not have a short introductory lecture, which if required, we have BT229 allocated to that. The Otherwise, all of the lab experiments will be in the main electronics lab, which the room number, they keep changing on it, but it's the only electronics lab now on the second floor. I think it's C234 now. Ignore what's on Dal Online. That will be where all the labs are happening. But I'll be using BRIGHTSPACE quite a bit, so I'm going to try to post if there is a introductory lecture or not. If there's not, I'll try to post something on the B229 whiteboard that there's not, in case you go there. Yeah, so the short quizzes, as I said, happen on most Wednesdays. This is in the schedule, what days this occurs. The first one, I think I'm saying, is next Wednesday, so the 16th of January. There's a total of 9 quizzes. Automatically, 2 of the worst ones, or ones you missed for whatever reason, will be dropped. So that's if, you got a bad mark. That's if you just didn't make it in because you slept in, anything like that. There's additional considerations for snowstorms, which are probably going to affect us, or illness. So because they're really short and quick, there's no makeup system. Basically, quizzes quizzes missed for legitimate reasons will then be dropped. This is why we have 9 quizzes, because you imagine we start with 9, automatically you drop 2, and then probably, if we have a snowstorm or 2, you end up dropping 1 or 2 more. Or if you're sick, that might be another one missed or something like that. So I want to make sure there's still some reasonable evaluation of your knowledge in this without having none to average. For illnesses, this is described in the syllabus as well. What I'm using is, so there's a, where is this? So there's a self-reporting system basically, that rather than having to go to the doctor and stuff to say I was sick, if you just had the flu, don't waste your time doing that. There's a self-reporting system you can use for two sick times, which can be used for quizzes or labs. It's not allowed to be used for the final or the lab final. But it is okay for labs or these short quizzes as well. So just make sure you have that where's that located? It was in the syllabus. Yeah. Anyway, somewhere there's a link to the self-reporting system. So you can use that for if you are sick. So how this course is going to be evaluated, the in-class quizzes, as I mentioned, will be averaged out, however many there end up being, and that'll be 15% of your mark. There's lab reports. These are due approximately, there's a separate document that I'm going to be posting on BRIGHTSPACE with the actual deadlines. It's a little over 1 week after the lab, so I think it's set as either Thursday mornings is when they're due, so you'll have a full week, and then an extra little bit is the typical deadline. There's also going to be a design or research project, and so this will be worth 15% of your mark. This project will be basically a chance to do a bit of research or an implementation of something of interest to you and of relevance to the course. So I'll talk quickly about that, but we'll go into more detail in a few weeks about this project. I don't anticipate anyone starting it yet. But feel free to sort of think a little bit about it. As I mentioned, there is a short final lab exam. This final lab exam covers anything that could have occurred in the labs. The objective of the lab exam is basically, if you've completed all the labs, then the lab exam should be no problem. That's sort of how it's structured. And so it sort of helps validate that some of the real world skills we claim to teach, you've actually sort of picked them up and understand how they work. The final exam, which will be during the exam period, is then worth 30% of your mark. And it's sort of a final standard final exam, which we'll have more details about later. So there's 8 lab reports. You'll notice one of the labs is split into 3A and 3B, basically because there's only one lab report for those 2 weeks. The labs are done, I believe everyone should sort of have a lab partner already. So the labs are done in the standard partner setup. If there's any problems, let me know with that, of course. What we're going to be looking at is a wired protocol stack. So we'll be looking at Ethernet in particular, what the protocols look like on that. We'll be looking at wireless protocol stacks next, which will again be a chance to sort of see how these work in real life. We're then going to be looking at applications using the software-defined radio. So most of these labs will now be using that software-defined radio platform. So we're going to begin with effectively having me transmit a signal, and then you'll be receiving that signal. And there's 2 weeks dedicated to this because, you know, we're now moving from a really simple theory to actual real life, and you'll discover that there's quite a bit of you know, things that make it more complicated than it seems in textbook. We'll then be sort of dealing with a lot of different demodulations, so you'll be looking at QAM as one method that you'll be interested in being able to actually see what the constellations look like. Some of the remaining labs will look at error detection and correction, so CRC and forward error correction. This is more a simulation lab. And we'll also look at decoding some protocols, so you can actually do some pretty interesting work decoding real signals. So a lot of these will use pre-recorded signals just because we don't necessarily have the capability to get everyone to receive these real time. But again, the objective of this is to look at what happens in real life when you go to decode some of these signals and how do those systems actually work. So most of this section here will be done with Simulink. Oops. And the first two will be mostly looking at something called Wireshark, which is like an analyzer. So Wireshark will let us analyze data going over the wire. Simulink is sort of a simulation environment that I think most people have used already. And we're going to be interfacing that to physical hardware for these labs. The project, so you have a choice of individually if you want, or groups of 1 to 4 students. And there's basically 2 deliverables for this project. There's going to be a short report, which is basically ensuring you're on track. It's, you know, what's your chosen topic, what's work breakdown, problems, expected final deliverable. The final report is basically, again, not excessively long, 4 to 10 pages. There can be appendixes to this. This is sort of the core part of it, which will include the background research goals and results of your project. Now the project has 2 types, so it's a little generic in what I said in the previous slide, because there's basically 2 options. And you're going to decide in your interim report, you're going to specify what you're planning on doing. One of them is a research-based project. So this will mean you're going to pick something and say, I want to do a lot of research on this topic. And I expect the end result of this to be a reasonable research report that's looking at from historical to current state of the art on whatever your chosen topic is. The other option is to look more at implementation based. So even though both of these generate a report, the difference between them is obviously if it's research based, I'm looking for a lot more detail in the report to see that it looks more like a research paper that's spending a lot more time going into the background, the current state of the art and stuff like that. The implementation-based project, you've primarily been focusing on a real implementation. So you've said, I want to look at this protocol, I want to look at this wireless communication system, and I'm going to try to implement a version of it, a section of it, and the report just will have a very short background and then detail most of the work that you've done and what the results of that are. So I sort of leave both those options there because they're both of interest to this course and they're both relatively relevant to you. So to give you sort of what that might look like, you might say, okay, I want to look at a cellular LTE protocol. If you were doing a research type project, I'd expect to see a background of the historical protocols that led up to the current LTE. What's the underlying technologies used? You may derive a few formulas or relevant information related to the technologies used in LTE. And then detailed comparisons between, okay, what's next generation, what are previous generation, how does the performance compare? Now, if you took that exact same topic and said, I want to do an implementation project, your report would look something like this. So there's just a short background section, and the rest of the report is describing basically what you've done and what the results were. So I implemented part of LTE in GNU Radio or Simulink or something like that. And here's some details of it, here's some screenshots, here's what the results look like, and in the appendix, here's the full design of it. So you can see the real difference here is that one of these goes into a lot more detail on the actual topic. One of them does some sort of brief background on the topic relevant for you, and then details of the work you've done yourself. Question, yeah?
If we're doing a hardware-based project, are we on our own for providing hardware?
Yeah, so if you need any hardware that they don't have, then there's no budget for the project. Okay, I guess that's the question. So if there's anything specific, like let me know. I don't know if they have anything here. There might be something that can be borrowed for the project.
Okay.
But yeah, I don't. There's no exact design on it that way. So if you're doing like a PCB, for example, there's no budget for getting PCB spun. Although it's something we can talk about if you're interested in it. Was there another question, sorry? Okay. Yeah, so I'm going to post some suggested topics. These aren't going to be definitive that you have to choose from. My suggestion is really take a more specific topic. So I gave the cellular LTE example, which is really broad, and you're going to spend tons of time doing research. But you might be more interested in saying, you know what, I want to look at, here's a really specific area within LTE that, maybe how it was implemented in one of the first phones, or here's how one of the issues they had in developing it. If you choose sort of a more narrow scope, it's probably going to help you focus the research, especially if you're doing implementation. You're going to, not want to spend weeks and weeks and weeks implementing the entire protocol because you'll just run out of time most likely. And for the implementation, don't obviously just pick like, hey, here's an open source project, let me just write up that. So the objective is to take something and extend it, or build your own system or something like that. So that's why I say more specific is valuable, because this will let you really focus in on what you've actually done. So the other policy in here is the note on the academic honesty policy. So there's two oaths, they're two sort of general statements that I think are in every course. Academic integrity, that you have to demonstrate these values you do. There's a separate one as an engineer that you will end up sort of swearing that you will uphold the values of truth, honesty, and trustworthiness. So we put a pretty high expectation on you for this. And this is also one of the reasons that some of the things are structured the way they are, for example. So the quizzes are all fairly rapid in class, because it's a pretty easy way to validate what you actually know, and not that someone else has done this quiz for you. So hopefully you don't find yourself in the discipline process. Basically what happens is, normally the first time it happens, you get added to a database, and if you end up in this database, then it's a lot worse the second time things happen. So I'm very happy to follow this, so please do not try submitting work that's not yours. Please, if you think, if for the quizzes, for example, that's one of the reasons I have I just dropped to, is that you don't feel like you absolutely have to make every single quiz or cheat on a quiz or something like that. Because if you have something come up, you can just drop one of the quizzes. That's sort of one of the objectives of the setup. If you have questions, so these are my general office hours I'm trying to hold. I'm in room 2003. This is across in the new building, like across the little pedway thing. Tuesdays, I'll try to be there from 12 to 1, and Wednesdays from 10 to 11. You can also email me, so I didn't put my email on the slide, but it is on the, it's on this as well. I'm not sure what all other courses are. Sometimes these will conflict with other courses. So typically before or after courses as well, I'll be around to talk to if you have any questions. So please feel free to talk to me. For actual course material, I've turned on Blackboard, or BRIGHTSPACE, sorry, not Blackboard, this form. If you post anything on the form, I automatically get an email. So this is as fast and likely a faster response if it's non-confidential requests that you have. Because anything in here as well, the TAs will get, obviously other students will see this too. This is sort of the preferred method of keeping discussions, because if you have a question, also likely other people have questions. So I really appreciate people using the form, because I think it'll help, it helps me also see if a lot of people say like, oh, you know what, this lab isn't working, or that's something you didn't cover. If I see this here, it can be a little more obvious that there's a few people with this problem. This course also, and this wasn't in the printed handout, it'll be on the online one. So there is a supplemental exam per sort of the department policy. So there's rules around if your final mark is, you can take this supplemental exam. But the course will have one, just so you're aware. I didn't actually put it in this printed version you have, but it'll be in the written details online on BRIGHTSPACE as well. So yeah, that's sort of the really quick overview. I guess if people have any questions now on stuff or stuff that wasn't clear on the class plans, or any concerns with, yeah, topics covered or things that I'm assuming. Yeah.
The USB SDR sticks, are they available?
Yeah, so these sticks are available. I believe they'll be set up. They're a new thing, so this is why the first few labs, also why that first lab has a lot of time, is because this is the first time we're using them in this lab. So I think they have 40 or so in that lab, and all the computers should be set up with Simulink and stuff to run these. So, yeah, and the other thing too, so one of the lab times you'll note while I'm away is marked as a project time. So basically this will be a time if you need specifically lab time, this will also be a chance to do that because you'll have full access to the lab. Obviously beyond, sometimes you can get access to it in other times too, but this will be sort of a dedicated space for it. There also will be 2 TAs for the course. So there's 1 TA contact on the front. There's a second TBD. I don't think it was confirmed yet who the second TA was, but they will also be available if you have questions or problems or anything like that. All right. If not, that's actually, so I basically wanted to just cover the syllabus stuff. I think we'll spin into more introduction in the next full class, but otherwise that should be it. So.